Hello. Now I'm going to present the questions that I got in the integrative activity part 2. And here it says relate the following properties with each compound. And here we have methyl trichloride and sodium hydroxide. Um, First, we need to see which one is an organic and which one is the inorganic. The organic is the chloroform or methyl trichloride because of this carbon hydrogen bond that usually that it's very rare in an inorganic compound, but it's very common in an organic compound. And the sodium hydroxide that doesn't have any carbon, so that's the key to know that this one is the inorganic compound. With that, we know that the organic compounds evaporates easily, have a low boiling point, and are flammable, and also doesn't mix with water very well. They are really soluble on nonpolar liquids, and water is a polar liquid. So the chloroform has the properties of evaporating easily, a boiling point of 62 degrees Celsius, and that is slightly soluble in water. And the rest are for the sodium hydroxide that it is white, crystalline, solid, and non-flammable, and that it has a melting point really high at 318 degrees Celsius. The next question is that this student analyzed a substance and he got the following results. Now we have to determine if the substance is organic or inorganic, depending of the test with solubility in nonpolar solvents, as we mentioned before. That is a characteristic of an organic element. The melting point is at 1,256 Celsius degrees, which is a really high melting point, and it has no flammability. With that, we can know that it is an inorganic because the inorganics usually solve in pol in polar solvents and has really high melting points, and they are most likely to be to have electrical conductivity while they are in water, but since the melting point is that high, they aren't flammable. To finish with, we now have a compound with this diagram. We has and it asks us to say how many type of bonds it has. Sigma bonds have how many sigma bonds does carbon one have? This is carbon one, and it have three sigma bonds because it have a double bond right here. If it were this one single bond, it would have four sigma bonds, and if it would be a three like this, it would have only two sigma bonds. The next question is how many hybrid orbitals does carbon 4 have and why? This is carbon 4 and it have eight or hybrid orbitals because it only have it have a single bond right here and another single bond right here, and each single bond adds four hybrid orbitals. The next question is what is the geometry of carbon 5 and why? It is a triagonal. Well, here is the carbon 5. There is a triagonal planar because of this double bond that defines that it is a triagonal planar, and the p bonds of carbon 2, and why how many carbon 2 has 3, because well, no, uh, the carbon 2 has two p bonds that corresponds to this triple bond that it has with this other carbon. And I can know all that because of the chart that the teacher gave to us that it tells us the relation between these bonds and each one of these other characteristics that the compounds have.